Hello everyone, I am Dr. RGD from this is PrepMed NEET channel. Today I am going to talk about here a very important concept and a very short tricks to calculate the order of a reaction. Now see, order of the reaction determining it's been a challenge for all the students and everyone in the scientists who work on this field. Particularly if I say here one thing that when we determine the order of the reaction, we have to take care about many things. Number one, we have to focus on the rate of the reaction. Number two, we have to focus on how the reaction works. And number three, we have to focus on that how a reactant gets depleted to the product, means the way the reaction proceeds. Now see, there are four methods of determination of the order of the reaction. Number one, called initial rate method. Number two, integrated law. Number three, graphical, and last one is the method of half-life. Now these all methods are very straightforward and you don't need to think about that how it works or what it does. Sir, ye kaise hota hai, wo kaise hota hai. You don't need. You just need three things. You just need three things here. From these three methods, number one, we need the idea that what exactly it is. Number two, we need the equation or I would say beta working formula. Okay, and number three, we need that how to tackle problems, how to tackle numerical problems, how to tackle numericals. So these three things we basically need for this particular process. Now let's see the first one, that is your initial rate method. Okay, initial rate method. Now beta, what happens in this particular method? Let's talk about first initial rate method. Okay, now all of you one thing, ये video ना तुम लोग last तक देखो. Okay, because these all three methods, because the questions will come from these methods. मैंने जो questions आएगा ना, यही कोई भी एक मेथड यूज करके you basically have to do. So ये वीडियो लास्ट तक देखो and if you have any questions or any problems that कोई सॉल्व करते करते सर ये अटक गया, ये नहीं हो रहा है, सर ये गलत है, ये सही होना चाहिए, any if you have, you feel free to write in the comment section. चलो बेटा देखते हैं यहाँ पे. So when we say initial rate method, so definitely we will talk about the initial rate. Now what is the rate equation? If I go by the rate law for any reaction, let's say any reaction, let's say A2 products, I'm talking about any reaction beta, your A2 products, if I talk about, what I can say beta, rate is equal to rate constant into A to the power A. Correct? This is your rate. Now see, initial rate, R is the initial rate, and as the time proceeds, this R will change. Definitely the R will change accordingly. Okay, the thing is that here, that how the R will change, let's say I have two set of data of the same reaction, two set of data I have, and in these two set of data I have two things. Now initial, what we have here, we have two set of data. Let's say beta, this is your experiment number 1 and this is beta your experiment number 2. We have two set of data we have. So from here what we can say, R1, that is experiment number 1, is equal to KA0, okay, KA0 of reaction number 1 to the power A. Let's say my A is the order of the reaction, like here. Similarly in the experiment 2, what we have, R2 is equal to K into A0, into A0 2 to the power A. Now what we can write, since both of them have same rate constant, then what is the working formula? From here you can say R1 by R2 is equal to your A01 divided by A02 whole to the power A. Now from here, if I take the anti-log of this one, if I take the log, not anti-log, if I take the log of this one, in this case for the both side, what we will get here, log of R1 by R2 is equal to A log of A0 experiment 1 divided by A0 experiment 2. And from here we can easily, using this equation, we can easily determine the value of A. Easy beta, very simple. Okay, chalo next method पे आते हैं. Next method number 2. That next method is called your integrated rate law method. Integrated rate law method. Integrated rate law method. Now definitely one thing I will say here, if I look at the exact equation of the integrated rate law, so what it will, we know that beta rate is equal to nothing but your dc by dt for a reaction, and this is equal to what we can write, this is equal to, we can write rate constant multiplied your concentration to the power a. So this is a general rate law. Okay, तुम लोग सबको पता है, it's very simple, it's not a big deal. Now here what we will do, now here we can do one thing, that or we can write, देखो तो k into dt is equal to what we can write, dc by c to the power a, we can write dc by c to the power a, we can write. Okay, अच्छा, तार माने this is what we can write here. From here we can we write d of or dc by c, this we can write d of ln c by, let's say c0. अच्छा, ऐसे नहीं करेंगे, इसको छोड़ दो. From here let's say my initial concentration, let's say my initial concentration is equal to c0. So okay, initial concentration is c0. So from here what we can write, we can easily write the equation, that is your k is equal to t ln c0 by c. Okay, ln c0 by c we can write. Now the thing is that one totka I will say here, that this equation is only valid, this equation is only valid for, remember, first order reaction, for first order reaction, for first order reaction. This is only valid for your first order reaction. Okay, because here we cannot use, order is equal to 0. Here we cannot use your order is equal to 0. This one we cannot use, because if order is 0, then beta this part will be the undefined. This 0 is 1. When ln 1, so this is 1, then this will be undefined. Undefined, now this will be 0. This will be 0. Okay, if this is dependent, concentration independent, then 1, then ln 1 0. So there will be no dependence. So this equation will not be valid. So simply what we can say, this is only valid for first order reaction. And from here what we can say, from here it is easily what you can do, one thing, that easily what you can do, if I get a set of K's, let's say, if I get a set of K's, and if I get a C0 by C, if this data, using this one we can easily calculate this R is equal to K, let's say C to the power A. Now from here we can easily calculate beta this particular value, that what it is saying. So basically this is the complete core experimental technique to calculate the your order of the reaction. Clear? This is a very important, and this is only for the first order reaction we know. So yes, obviously your A ka value kya hoga? A ka value will be always 1. And from this data we can determine other quantities also, like we can determine the rate of the reaction also, and we can determine the T half of the reaction also we can determine. So lot of problems are there we can use, and one thing you should remember, that this method will be only applicable for the first order kinetics. Acha, next method, graphical method. This is a very simple method, graphical method. Okay, दिस इज अ वेरी सिंपल मेथड बेटा, ग्राफिकल मेथड. क्या होता है इसमें, you basically draw a graph. Now beta, what kind of graph? Let's say we have a equation r is equal to k into a to the power a. This equation we have. Now log of r is equal to what we can write? Log of k plus a to the power a. We can write this. Acha chalo. A log of a we can write. Now if I want to plot here one thing, that is log of a versus log of r, then I will get a graph like this, a straight line like this, and at the end of the day what we will get here, this slope will give me the a, that is the order of the reaction. This is a complete graphical method, but definitely in the exam or during doing the problem, definitely we are not going to get a graph paper. So for that what we will do, if you see beta, this order is basically nothing but the slope of the graph. So what we will do here, general slope, that is y2 minus y1 by beta x2 minus x1. That means if I use this logic, then what I will get, then definitely I will get beta y2 mane I will get log of r2 minus log of r1 divided by your log of a2 minus log of a2 minus log of a1. Okay, so this is your direct working equation for determination of the order of the reaction. And beta, the last method is called half-life method. Half-life method. This is very simple. Now let's say if I have an nth order reaction, suppose R is equal to your dC by dt is equal to rate constant into concentration of C to the power n. Suppose we have an nth order reaction. Now this nth order reaction, if I do integration to find the integrated equation along with your half-life of this reaction, what I will get a very interesting expression, that is T half will be proportional to 1 by C0, that is initial concentration, to the power n minus 1. So if I know the half-life or same equation in different conditions, we can easily from here what we can say, that T half of experiment 1 divided by T half of experiment 2 is equal to what I will get here beta, C0 of experiment 2 divided by C0 of experiment 1 to the power beta n minus 1. So this is your working formula for this half-life method. Fine. So hope you like this video. All of you, hope you like this video. Or remember one thing beta here, that these methods are until and unless it will be useful, until and unless you try in the numerical problems. Okay, so that's it. These 4 methods, revise this, do some problems, and if you have any questions and query, feel free to write on the comment section, and don't need to worry about these things, are very simple. So from my side, bye everyone, take care, and share with your friends this. If you like this video, like section and share with your friends. So from my side, bye everyone, take care, see you next time. Tada.